My name is Aviran. I'm head of engineering for Wix. And what I'm going to speak with you about is Wix's culture. It's a developer-centric culture. Basically, the story how we deploy, it says 2,000 times a day, so that's about right. And that's it. This is basically a 2-hour workshop, which I tried to scramble it into 1-hour talk. So I'm not sure that we'll have time for questions, but I'll stay here. So during the break, you can grab me, and we can speak. OK, so let's start. Everybody know what Wix is doing? I hope so. For those of you who forgot, Wix is a website building platform where everybody can build their own website. If you know PowerPoint, just drag and drop, and you'll get a beautiful website. A little bit numbers. We have over 100 million users. Those are the website builders that's using our platform. We host everything ourselves, so it's a full service. It's a little bit old, but it's over 5 petabytes of data, not 2. We run in 3 data centers, including Amazon and Google Clouds. We handle about 5 billion HTTP requests. I know it's not the right number. We're about 16 to 1,700 people already. And yes, it's a great workplace, as you can see. So, enough about those things. Let's talk about how we develop software. Okay. So everybody should know this flow. How software being developed in, unfortunately, too many companies. It starts with the product, where you have the product manager. They go, they write the product book, maybe a few hundred pages that define the product. Then they hand over the product to developers. They start writing code, they finish the code, hand it over to QA. They test it, if they approve it or not. Once they put the stamp of approval, it goes to operations, and hopefully they will run it on production. Who works this way here? Anybody? Good. No one. So this is a traditional waterfall. So waterfall, as we all know, has a long development cycles. Okay, it's a lot of time wasters. You're waiting a long time from what is QA doing while the developers are writing the code? They just wait for the code, right? What are the developers doing while product managers writing their product book? They just wait. Cheers. This, yeah, you drink beer. Yes, it's a good thing. So development cycles are really slow. It's about 1 to maybe 4 times a year. And our industry came to the conclusion that this is too small, this is too slow, we cannot progress, and we want to do something fast, something agile. And they came up with this thing that is called Scrum. So we have the product backlog, you have the sprint, you got pigs and elephants and chickens and what have you. It's about 2 to 4 week cycles. And after about a month, usually what happens is you start another sprint, right? Most of the time, nothing really happens. So it's kind of a waterfall, but we just put it in 2 to 4 week cycles. So we didn't like it so much. Scrum is okay for project management, but not for delivering software really fast. So it's not that agile. So we had a lot of evolutions with extreme programming, with Scrum, Agile, and Lean. And this is the story about what Wix was doing. Okay. When we started, about up until 2010, we were actually doing the waterfall thingy. Okay, we had long release cycles for about 3 months. After 3 months, we had like a QA deployed, and 3 months without getting any sleeps because we had to stabilize the version that we ran in production. Everybody know the phrase, "It's working, don't touch it." Yeah? Yeah. Yeah, we had a lot of things that we didn't touch, just too scared to touch it. And this caused a really, really big problem for us. We're a young startup. We were trying to progress fast and win the market. And we actually hit a wall where we couldn't move. So we needed to figure out how we can move fast. And remember, this was 2010. Fortunately, we didn't have to invent anything. I mean, this guy, his name is Taichi Ono. He was the production line manager for Toyota. He actually revolutionized the automobile industry. Up until Toyota came into play, automobiles were basically, the production line was invented by Henry Ford. And when he said, okay, I'm going to give a car for each person, he created the production line where he took unskilled workers and have them work in the plant. And the rule was the production line does not stop. You had one worker that's screwing one screw, the one that puts the wheel, the one that puts the doors. So it had a lot of unskilled workers, and it looked something like this. For those of you who, oops, wait, where is it? Where is it? Where is it? Yeah, oh, come on. It's not working. Okay, it looks something like this, if you know Charlie Chaplin. So, production line is working, you cannot stop. Production line never stops. And if you get sick, you just go to the street, bring another one instead of you, and just keep on working. Now, what is the result of this method? Yes, a lot of cars would go out from the production line. But the quality of the cars, it was just terrible. In software, we call them bugs. In cars, I don't know if I want to drive this kind of car. So what they did in Toyota, they said, okay, we're going to change this thing. First of all, we're not going to treat our employees as replaceable. We're going to treat them with dignity. We're going to respect them. We're going to ask for their opinions. The other thing that actually was kind of revolutionary to this time is what they did, he put a line around the production line with a string, and at the end of the string there was a bell. And what he told his employees is, if you see something that is going wrong in the production, you just pull the string, the bell will ring, we will stop the production lines. All the managers and the inspectors or the engineers will go from, they have like a rail on the top, they will go down, go directly to the source of the problem, they investigate it, they'll fix it, and only after it is fixed, we will continue. He did a lot of other things too. He eliminated the waste, he didn't order parts that weren't needed. He heard his employees, he got feedback from them. And essentially, he transformed the auto industry and created very high quality cars. And essentially, until the late 2000s, if you would have to buy an American car versus a Japanese car, Japanese car was much better in terms of quality. So how we can move fast in the software industry, taking those kind of concepts. We have to work lean. And we need to change our company structure in order to work this way. We need to change our architecture. We're changing our production line, basically. And continuous delivery is a big thing when we want to deliver things fast. Okay, so we'll go over those principles, and we'll see what we did. So what is lean? How do we work lean? So we want to eliminate the time wasters. Okay, so the biggest time wasters in our industry is features that nobody uses. Okay, so take for instance a great example for features that nobody uses. It's Microsoft Word. Okay, so you have 32% of the total command usage is those 5 commands. Okay, copy, paste, save. Now, think about a waste of time, okay, in Microsoft Word. Everybody uses Microsoft Word, I'm guessing, right? Or have used it, if not, if they didn't move to Google Docs. But from those of you who use Microsoft Word, did you know that that Word can actually run Visual Basic scripts? Yes. Anybody wouldn't buy Microsoft Word if it wasn't running Visual Basic script? Okay. How many man-years did Microsoft spend in order to make it? 5. 5 is low. So I know it's a big extreme example because Word is kind of very mature and they had to do something in order to make you buy this new version because it changes the year. But again, it's for a company, especially a startup, it's a big time waste when you invest something that not a lot of users will actually use. So we want to eliminate this waste, and we want to create a minimum viable product. So viable is very, very important. Minimum viable product, I mean the minimal product that produces value to our users. Okay, so think about logging dialog. Okay, I cannot have a logging dialog without sign up, right? And I cannot develop just the sign up because then I cannot log in. But can I launch, and I'm not saying this is the final product, but can my first version be sign up login without the forgot password? I can, right? I can put a forgot password, just send an email to whatever developer from the 2 developers in the startup, and he will recover your password. Okay, 2 days, maybe 3 days after that, I will develop, or if it really bothers me, and if you see a lot of people forgot their passwords, maybe I'll go and develop this feature because it's missing. Okay, so it's a minimum. Some things we do manually, that's fine. But the idea is to get the product very, very fast to our customers and get their feedback. Another thing that you can do is actually understand, will my users actually want this feature? This is something that we do occasionally in Twix. For instance, we wanted, one of our product managers, he had an idea that, hey, why won't we let our users communicate between each other? Okay, send like a private message or email or whatever. And we thought about it and we said, well, we're not sure. And we only had like 4 developers at the time. So we want to invest our developer time in something that is really useful. So what we did is we put a button on the home screen that says send email to your friend or something like this. And this button actually did nothing. Really. It did nothing except logging a log entry that says, okay, this user pressed the button to our BI system. And there was a message that they're coming soon. Okay? We tested engagement. We tested how many users are actually interested in these kind of features. Okay? We figured out that not a lot of users wanted it, so we diverted our efforts to something else that our user actually want. If we would have developed this feature, it would have minimal impact on our business. Okay? You actually see this in various ways when you surf the web. You know those cool startups that you hear about? And you said, hey, I want to use this product, and you get to this landing page, and all it says, okay, leave your email. Yeah, it's the same thing. So what it gives us is the ability to learn and fail fast. Okay? Now, the less I invest in something, in a feature, the easier for me is to understand that it's not going to go anywhere, and drop it and do something that we actually need. Okay? If I would have developed a feature that would take me, let's say, a year to develop. Okay, so after a year, I put it in front of my customers. Hey, look at my great new feature. It took me a whole year to develop. And then you see the usage is not that great. Our users don't really want it. It's not exactly what we expected. What will you do? You try to fix it. You try to adjust it. You'll keep investing more time in this not that great feature. Okay? Why are you doing this? Because, hey, you got emotionally attached. The business, hey, we already invested the whole year in this. We can't drop it, right? We'll try to improve it. So you invest another 6 months in improving something that shouldn't have been there in the first place. But if you have developed this minimal viable product and put it in front of your customers after a month, and you already got the feedback from them, and then said, hey, this is not really what we want, or nobody using it, it's easier for you to, okay, so we just wasted a month, let's drop it and do something else, than we wasted a year, so we have to make it work. Okay, so the whole idea is to get a quick feedback. Put something, it's not perfect, but has value. If it doesn't have value, of course, that you're going to fail. It has some value, but it's not perfect, in front of your customers, and start getting feedback. It also affects your roadmap, because you think, or the product manager, they think, okay, this is what the whole feature should look like. This is the new product. But the feedback that you get from your customers, if you put it in front of them, you say, hey, maybe you'll develop this thing before that thing, because our users want that. It's not what the product manager thinks that they want. You actually get the real feedback from your users. So we did that. Another thing that we understood is we need to change our company structure. Okay. So we were working on a monolith, and when you have a lot of people working on the same project, you get a huge, big, bloated project that everybody steps on top of each other. And Melvin Conway said, there's Conway's law, if you didn't hear about it, it's a great law. He said that your software architecture or your system architecture is defined by your company's organizational structure. What it means, basically, if you have small teams, you'll get small modular systems and decoupled. If you have large team, you'll get one big, huge monolith. And that's exactly what we have. We had everybody working on the same project. And we started to break our companies into small teams. Now, this affected the architecture. So we said, okay, we're going to break our company into small things. So how would that affect our architecture? By breaking our monolith into microservices. Okay, so we took our monolith, we broke it into microservices, which actually fit our new company structure. So we created small teams that created small services, and we put them in small rooms. If you walk into our offices, you'll see that the rooms can hold between 4 to 7 people. That's basically it. We have a bit of larger rooms sometimes, but that's the idea. 4 to 7 people. This is the size of the room. It's going to help us make sure that we won't create big, huge monoliths. Now, each team can be responsible for several microservices, but they will probably will not build this huge, gigantic monolith. Yes, constrained by the size of our rooms. It helps. It helps. We don't work in open spaces. Besides that we're Israelis and we cannot work in open spaces because with too much noise. But yeah, we work in small teams because we gain a lot of velocity and decoupled. Once you need to go to another room, we are lazy, okay? And developers especially don't like to speak with anyone. So it's okay, you can speak someone in your room, but when you have to get up from your chair to the next room or to another whole new floor, you probably won't gonna do that. So you will try to decouple as much as you can, just not to speak with anyone else, right? Now, when you do microservices is not just like code. It's not like a library, okay? When you have the library, everybody have code that you say, okay, this code is like 3 years old. Nobody knows how to maintain it, right? It's a piece of shit because it's been written like a month ago, or the developer left. And everybody have an abandoned code if you do it long enough. Well, for microservices, it cannot happen, okay? Microservices have ownership. It's not a library. Every microservice is owned by a team, okay? They babysit it, they deploy it, they run it in production, they monitor it. They wake up in the middle of the night if something bad is happening to this service. Okay, it's a complete ownership. This comes where DevOps come into place. Every team owns their own microservice. Okay, if a person if one person in a team responsible for a microservice, first of all, it's bad because it doesn't have a redundancy and it will never go home to sleep or a vacation. But let's say it happens sometimes. When this person leaves the team, there are two things that can happen. The microservice ownership will stay in that team and they will have to maintain it. Or this person, if they move inside the company, can take this microservice to their new team. Okay, so no microservice is left behind. You build it, you run it. Now, speaking of moving fast, we actually want to move fast. So we switched to, instead of 3 months deployment cycles, we switched to continuous delivery. Now, continuous delivery is contrary to what a lot of people think. It's not an engineering concern at all. It's actually a business concern, okay? Because continuous delivery is actually risk management. Now, if you think about what is risk to your business if you're an online business? Every time you ship new code, you have risk, okay? So if you take this formula that risk equals the number of deployments times the chance that something will go wrong, and what is the impact in dollars or money or shekels or whatever, okay? So one second. So if you take Waterfall, for example, when you have very few releases in a year, so you have very few deployments, but the amount of code that is going in a 3 month or 6 month cycle is huge. And the more code you have, the more chances that you will have bugs, and the impact is greater. Okay? Continuous delivery actually is doing the opposite. It increases the number of deployments and reduces the chance that something will go wrong because, hey, if I just deployed 10 lines of code, probably I can handle 10 lines of code and I will have less bugs. And of course, if something does go wrong, I mean, the impact is a lot less than I just deployed 100,000 lines of code and the whole system crashed. Okay, yes? I compare that to? If I compare it to the risk of the opportunity risk, it's also about that. I mean, you can react a lot faster if you have a short release cycles. But yeah, it's also one of the factors. A lot of sometimes it's not about opportunities. It's about, hey, your system just crashed. Yes, you're fucked. So yeah, so my point is that continuous delivery is not an engineering concern. Yes, it's fun working continuous delivery, but it's a business concern. Okay, companies that don't do continuous delivery, that compete with companies that do continuous delivery will lose. It's that simple. It's that simple. Because you can react faster, your system is more stable, and if you progress slower, you will eventually lose. It might take time, but you will lose. So the whole idea is small iterations. Okay, it's no waterfall. We don't need Scrum to manage our release cycles. It's fine for project management. You don't need a lot of iterations. If it's ready, just ship it. Ship it. You don't need to have any approval from anyone. You build something small, you test it, you measure it. If it's not good, then fix it. When it's being done rapidly, you gain a lot. Okay, and you repeat it. So every time that you repeat it, it has to be easier. But in order to do that, we have to break the barriers that we have inside our companies. Okay, because we have our product, we have our devs, we have our QAs, we have our operations. If you think about it, I mean, there's something that is common between all those functions. Product, project, QA, operations, DBAs, those are all the functions in our organizations that are responsible for releasing our product, right? But there's something common between them, okay? The one thing that is common is that developers can do it. Really, they're not expert, but they can do it. Think about your startup. Okay, you got a two-company startup. Who are those two people? At least one of them will be a developer, right? It's not that you bring. Okay, the first person I'm gonna bring to my startup is DBA or QA. No, the first person that you bring to a startup is a developer. And this poor developer will not sleep at night, but will have to maintain the database, will have to deploy, will have to do everything that these people are doing. He's not an expert, but developers have the knowledge and they can do at least a decent job in every aspect of this product. So, taking this idea, we created our culture, okay, our developer-centric culture. So we say it's the developer's responsibility to ship product into production. And they need to do it in the best way, in the highest quality, and very, very fast. So our developers need to be involved in the product definition. They work with product to understand the product, to give feedback on the product. They do the development. They do the testings themselves. On the server side, for instance, we have 0 QA. Okay, we only need QA when you have a front end and UI because the person needs to look if it's good. But a lot of automations there too. They do the deployments, they do the rollback, the monitor, they own it, they monitor it, they run it. They basically do everything. They're not the experts, okay? The whole organization, we have subject experts, okay? The DBAs support the developers reviewing their queries or the schemas, okay? The ops guys are building the tools to allow developers to deploy to productions, okay? QAs, they're helping developers in understanding, okay, what do I need to test? And they help them test it. But they're not doing the jobs for them, they're supporting them. Okay, so the whole company is basically revolves around enabling the developers ship our product as fast as we can and in the highest quality as possible. So continuous delivery is basically a culture. Okay, it's a culture and a mindset. So we trust our developers and empowering them in creating and releasing products to production as fast as they can. Okay, when something goes wrong, okay, who's the best person who knows the system the best? Okay, it's not the product that defined the product. It's not the QA that tested it. It's not the operations that actually operate it in production. It's the actual person that actually wrote the system. They know the system best. Okay, so it's their responsibility. And we want to support them in creating those things. And so automation is a default. Everything has to be automated. Okay, there is no question, is it worth automating? If you're doing something more than once, automate it. Okay? Can I say that enough times? Everything has to be automated. Okay? And if it's not automated, automate it. And we like to work in a kind of a twilight zone. Not everything has to be formal. Product and developers and QA's boundaries are going down. They sit in the same room. We try in most of the time that they will sit in the same room, or if the rooms are small, then at least in the same floor or a room next to them, so they can speak. They don't need documents going back and forth. They just, if what a developer needs in order to develop something is, okay, give me a screen. Just draw me a screen. I will probably understand 95% of what you want just by looking at the screen that you want me to design. Okay, the other 5% I will just ask you, okay, what do you want in an edge case where error is happening when I click this button? Yes, ask your product, but ask them. Okay? 95% of the functionality, I don't need you to explain. I can understand. Okay, if it says field name and address, I don't need product manager to write, put in the name here and put in the address there. Okay? Stupid. It's a waste of time. And caring. Everybody needs to care about everything. If something goes wrong in production, if something goes wrong in the project, we wake up everyone. It's not just the developers. We wake up the product managers in the middle of the night. We wake up the company managers. Everybody that is responsible for this is going to wake up. Okay? It's not the ops. They will wake up anyway. Ops will wake up, developers will wake up, product managers will wake up. Everybody will wake up. They have to care. Okay? And fix it, and in the morning we'll just do a postmortem. And less formality, you don't need a lot of meetings. If they sit in the same room or in the vicinity, we just talk. I know, we don't like to talk to anyone, but we need to talk. So, the basic principles. The process has to be repeatable, okay? And every time we repeat the process, it has to be easier and reliable. Did I mention about automation? Something? I said something about automation. Has to be automated, everything. Okay? We want to move fast. If something is painful and difficult, then do it again. Do it often. It will become easier. Okay? Everything is source control. We have here the GitHub. Everything is source control. Everything is version. Everything is versioned. Okay? when we work in this mode, I mean, what does it mean actually a release? What is a version? There's no concept of versions anymore. Okay, you just ship it, ship it, ship it, ship it. You fix the bug, you fix 2 lines of code, deploy it. It's easy. It takes 2 minutes. Ship it. You don't have to wait. Okay? And the definition of done means I released it, it's good, I don't ever have to touch it again, I move to something else. I start developing my new features, my new tasks. Okay? When I click release, it's GA in production, that's it, I'm done. I'm in Wix it's 97%. 97% sure that I will not have bugs. And everything is good. It's a real number, 97%. If we release something, 97% of the time it's fine. Only 3% bugs are discovered once it went to production. Now, in order to do that, we have to build quality into this process. Okay, it has to be high quality. And we firmly believed in TDD. Okay, in test-driven development. So no code is being pushed to Git without being fully tested. We call legacy code is code that was written before we moved to TDD that is not tested. If a bug is discovered there, the first thing that you need to do is write a test and fix the bug, and then the test will be green. Okay, and this way we try to cover the legacy project. We don't stop everything and say, okay, we're gonna stop everything and write all the tests now, but it's okay, it's working, but if we have to fix something or we have to add anything to it, we just start from there. When people talk about TDD and think about TDD, I hear this a lot. They say that TDD slows down your development, you write a lot more code, and it's okay, I have great quality as it is. I don't need TDD. From our experience, and I guess many others, only one sentence here is right. Yes, you write more code. For Wix, 80% of our code is tests. 80%. But we reach to production about 50% faster. Okay? In tremendously higher quality. Okay, they're almost, like I said, it's 97% of the times when it's being released, we don't find any bugs in production. Okay, if you want to learn TDD, this is our Bible. Every developer in Wix get this book when they join. This is how we do TDD by this book. And there is no more thing that is called, okay, it's working, don't touch it because I'm afraid. In Wix, we said if you didn't touch anything for a while, it's probably time to do something about it. Touch it, deploy it. We actually have a process that a microservice that hasn't been deployed for over 30 days, but it's fine because maybe it didn't have any changes, has to be deployed. Every 30 days, everything has to be deployed, recompiled with all the latest frameworks, with all the latest libraries, and redeployed. Okay, so we have alerts. We're actually building an automation with that it will be deployed automatically. But we have alerts for that currently, that everything that has not been deployed in 30 days will trigger an alert, and we will deploy it. We'll rebuild it and deploy it. Now, one thing that really helps our quality and maintaining our quality and velocity, which is very, very important if you want to move fast, is refactoring. Okay, this is a hack. We don't like hacks. So, refactoring is not rework. Okay. It's an outcome of learning, of something that you need to change the system that when you wrote it, you had this knowledge about these requirements. Now something has changed, and you can either do a hack in maybe a short time, or you can invest the time, do the refactoring, prepare the system for this new feature, which will be good and with high quality, and then write the feature. Now, it's not a question, you don't have to ask permissions to do refactoring. It's part of the developer's work. Okay, you don't. Sometimes it's fine, it's okay to negotiate, because if the cost of doing the refactoring is very, very high, and you say, okay, I can do this hack in a day, it will take me about a week to refactor. It's fine. One thing that Wix doesn't have is rules. Okay, we have a lot of guidelines and best practices, but don't have rules. Okay, it's okay to negotiate with your product manager. Say, okay, I can give you this in a week with good quality. I can do this hack in 1 day, but if I'll do this hack in 1 day, I will need a week and a half just to fix it. Now it's your choice. And it happens sometimes. Sometimes it's important to bring something in 1 day, okay? But it pays for the long term, okay? Because maybe this feature will cost me more or longer time to do, but the next feature that you'll ask me will be much easier. I will not put a hack on hack on hack and eventually will stop and have to do a complete rewrite. I will just pay the technical debt as soon as I get it. Now, one thing that really helps in mitigating risk when you do continuous delivery is feature toggles. Okay. What is feature toggle? Feature toggle is basically if in the code. Okay. So you write if the feature toggle is open, do the new code. If not, do the old code. This is an example for feature. It's an old feature toggle framework that we have. We actually have a new one. It's called P3. It's open source, so you can use it. It manages feature toggles and A/B tests. So this is just the if it's not, then do this. If it is, then do that. But it allows us to develop on master, okay? Because who likes to do merges? Right, merge in code, yeah. So it's not fun. Everybody develop on master. Okay, if you have a new code, you have a new feature. First of all, you block it in an if statement. Feature toggle is off. Everything is valid. It's fine. It is safe. It is being deployed even if it's not ready. It has to compile. Okay, it has to be built, but it doesn't have to be ready to be deployed. You have no control on when it will be deployed because other team members can deploy your code. It's fine. We don't keep code more than 1 day in our local environment, just being pushed. But it's been closed in feature toggles. Okay, so unused code is deployed. When you think it's ready, you can actually go and test it in production because it's there. Okay. You can control who sees it and how to open feature toggles. There's a whole, we just don't have time for that. You can talk with me later. But you can actually control when to open, who to open, what is your test group, and how to open the feature toggles and expose it to users, to internal users, to QA. You can actually do QA on production. Now, one thing that is really, really important is no more downtimes. You all know the website that have this down for maintenance? Yeah? If you deploy 200 times a day, can we have down for maintenance 200 times? That will be down probably most of the day until we go to sleep. So you cannot have downtimes. Do I have time? I don't think I have time for this, but one of the harder things, and then you can, I have a blog post if you want to read about it, or you can just catch me later. One of the harder things to do without downtime is database schema changes. There's a whole flow that uses feature toggles in order to control how do you do data migration, how do you change schemas. This is the flow. The presentation will be available, but I just don't have time to go over it. If you want, I can send you the blog post. So like I said, we can open feature toggles to company employees. We identify users by geographic location, by languages, by user agents, profile, anything that you know, that you have about the context of the request. You can actually filter it out and open the feature toggle just for that request, or just for that person, okay, or just for this group of people. You can actually open feature toggles on specific servers. Okay, so if you run in a cluster, you deploy everything, but this new feature is, let's say, you change something in a complex computational algorithm, okay? And you have, let's say, 5 machines in the cluster. And it's risky, okay? Because you can have memory leaks, you can have a lot of I/O or CPU storm or whatever. You don't want the whole cluster to be brought down once you open it, so you can actually select, okay, I just want one server out of this cluster to have this new feature. So a lot of flexibility there that you can choose to do the risk mitigation and keep it moving and test it. Everything has to be monitored, of course. So this is Wix P3. Like I said, it's open sourced. You can manage A/B tests and feature toggles there. You can download it, play with it if you want. Yes? Great question. With so many feature toggles, how do we know? Well, first of all, we have this UI. Second, I mean, it's a whole workflow of how you open feature toggles and A/B test. Everything has a date. You get alerts. You get emails. Who is responsible? It depends. It can be the developers who are responsible to open feature toggles. It can be product managers that are responsible to open things in A/B tests, for instance. It can be both. It's someone asked for this feature. Usually, a lot of the times it's the product managers that are responsible to open it. So we provide them with nice, semi-nice UI tool. Everything is monitored. They get reports. They get alerts. All the team gets the alerts. And basically, they're responsible for the life cycle of this feature. Once it's gradually opened until it's open to all the users. There's a whole talk, if you want. I can send you a link about how we do A/B test and feature toggles. It's a complete science. It's another hour. It can talk about it, how it actually works. So how do you deploy to production? We take the cluster. We put everything on this cluster. Not really. Deployment is done gradually. And one of the key points that you need to keep in mind is keeping compatibility, okay? Backward and forward compatibility, because you have multiple versions of the same service, okay? You have a cluster, you deploy to one server, suddenly this one has a new version, the other cluster has the old versions. You roll out it gradually, you can do a rollback. You have to maintain compatibility. This is actually most of the times that we fail deployments, it's on compatibility issues between versions. It's really hard to actually test, to write tests for it. One thing that we put inside our internal frameworks to help us with the deployment is actually self-test. So every service, it's part of our framework, so every service that is being deployed, when it first starts up, it tests itself to see, can I actually function? And what I mean by test itself, it tests all its dependencies. So if the service needs a database, it will try to connect to a database, see, hey, I got a connection to the database. Why do we need this? Because if you think about it, hey, I do TDD, everything runs in my environment. What's different between my laptop and the production system? Configuration. That's the only thing that should be different. Configuration and the environment. So when you actually run the self-test, it says, okay, I didn't forget to configure instead of my localhost database to actually configure the real database. Okay, so I check to see if I have all the dependencies that the service needs. And in order to do that, 1 second, when something goes wrong, we developers really like to go and do SSH and log into a machine and check the logs, right? Who likes to do that? You should work in system, and you should work in system too. We don't. We developers, we're lazy. We like to look at nice GUI interfaces. So we have web pages inside that actually expose everything. If you want to enable developers and make it easy for them to actually maintain production, expose everything in a nice GUI. If you have an exception, this is, for instance, an example of what happened when a self-test failed. You see the stack trace. I don't have to go and SSH to a machine, go to the VPN, go look for the logs and do a grep and somehow figure out, okay, what was the exception that caused the self-test to fail. I can just go into the screen and see it immediately. Okay, so bring production closer to developers, make it easy for them to actually maintain it. Okay, so we talked about backward and forward compatible, not going to repeat it. Oh, we're almost done. So, where were we in 2016? So we did about 28,000 deployments in last year, which means our production changes about every 4.5 minutes. And that's not including if we start now opening the feature toggles and A/B tests, which actually changes the state of our environment like every 3 minutes. Yeah, it's about 200 times a day. So it's not that hard. It's not that scary once you have everything. It's a big investment. Yeah, don't get me wrong. Okay. But if you follow those principles, put in built-in quality, we do with TDD, with small iterations, you keep the compatibility, you do gradual deployments, use feature toggles and A/B tests and monitoring. You make the production visible. It's doable, it's easy. Developers who work in a continuous delivery environment, and I can also tell you that developers that actually work and develop using TDD don't want to do it any other way. Okay? I know it's hard to do, it's hard to learn, but once you do it, you don't want to do it any other way. So these are some of the tools that, like I said, we bring the production to developers, and it's really, really important. So everything is monitored. This is part of our internal framework. You just go into the screen. Yes, I know. I'm almost done. You can see performance. You can see the recent exceptions. You can see actually the logs. You don't have to go to machines to see the log. We expose it via this interface. Everything that we added there is because we had a problem and we needed to see and get more information, so we added this throttlers and resource pools. New Relic is a very good friend of ours. Every room that we have developers have a big screen with monitoring system on it. One thing that I want to show you, this is an old version, how we configure our production environment. It's called Frying Pan. This is the servers and what service is running on the server. Now I want you to check out this button here. It says destroy. Remember that I told you about trust? Everybody, all the developers have access to this tool. They can click it and destroy the whole production system. It's the same, well, we need to destroy because we use the same system to build our staging environments. Like I said, this is what happened when you let a backend developer develop a UI. Okay, it doesn't look this way now. We moved the destroy somewhere. We hid it in a menu, and there's "Are you sure?" over there. We have a few close calls there. But the idea is trust. Okay, we trust that people will not click destroy and destroy our production environment. Okay, so we build tools around our build system and deploy. You can see the progress and then have access to everything in production. And I told you about 97%. It's an old, it's from 2014. So I looked for like a very bad week. So the blue line is the total number of releases and rollbacks. The red line is actually GA'd, it's deployment to production. And the yellow line there is rollbacks, okay? This is, all the rollbacks are on a legacy system that is not tested, like a really, really old legacy system, like 7 years old. But yeah, I mean, this is, once you do all these things, you get to really, really high confidence that the code that you release is good, and you're done. You release the code and you're done. You can move on to the new thing and move very, very fast. Okay, now Dan is gonna kill me. This is the end. Remember, follow Wix Engineering Twitter account. The quiz is gonna be released right now. If you wanna win this nice, cool prize. And thank you very much. There are pizzas outside. I am gonna stay here. You can ask me questions during the break. Thank you.